More importantly, tonight I want to give special thanks to our sponsor, which is AWS Elemental, and we have a special guest here tonight. Thank you, Brian. And and of course tonight's speakers and all of you that come out. So let's jump into it. We're going to start off with cloud switching, enabled and optimized media workflows in the cloud with Fayez and Casey Phillips.
All right. You guys hear me okay? All right. Cassidy Phillips. I'm a lead solutions architect at SWTCH.io, and I'm joined by my friend Al. Go ahead and tell them who you are, Al.
Hi, my name is Al Fayez. I'm Director of Engineering at SWTCH.
So we're going to talk about enabling multicast and other types of more on-prem routing in the cloud and what we can do with that. So go ahead and give me the next slide, Al. So we have a parent company, IEX, that was looking to use multicast in a cloud environment, a data center environment. And you guys probably know that's been a big no-no for a long time. So they worked with our founders, Jeter Karazis and Brent Yates, to create SWTCH.io, which was launched in January 2021 and was designed to enable easy migration to the cloud of those on-prem multicast type workflows. And there's some other details in there, but we'll get into that, or Al will. So Al, what's the problem exactly when you're trying to migrate these workflows into the cloud?
Hi. One of the big problems that we worked on addressing to begin with was lack of high-performance multicast in the cloud. And in addition, the ability to easily push that multicast data to and off on-prem. So this was the first thing that SWTCH.io has worked on. And as you know, the benefit of multicast is you're able to reduce the pressure on the origination of the signal that you're pushing. So basically, instead of having to create signals and push it to multiple Unicast streams, you're able to set up a pipe, and parties that are interested, they can subscribe and receive the data from there. So basically, what is CloudSwitch? So from a hands-on perspective, a CloudSwitch is a software image that you bring up on a VM or an EC2 instance that you own. So basically, you own that machine, you own the resources, it runs in your own tenant, and you have full control of it. It's not a SaaS, we don't get any of the data that you're running on it. And in order to create an overlay network for your workflow in the cloud or on-prem, we have an agent-side service. So that is basically a virtual NIC that you run on your agents. And by doing that, we're able to do tunneling and untunneling and basically do everything without having to interface with some of the limitations in the cloud. So we started with multicast, but basically as we worked with more customers, we noticed that there are more things that we can do, and we added more features to our product. So one of the first things that we wanted to do is basically provide customers with a consistent experience across all clouds and on-prem. So we wanted to have the same product, you set it up the same, and everything is seamless for the customer. We're currently available on Azure and AWS Marketplace, and we are available in limited beta testing right now in GCP and OCI, and we're working on making it available in the marketplace there. We also had customers that basically interact with hybrid workflows. And what that means is they might be moving to the cloud, so basically they have a mixture of an on-prem environment and a cloud environment, or they might need to have just naturally the flow requires origination from the cloud and or from on-prem and or termination with on-prem. So basically we added the feature of being able to run the cloud switch on-prem in a bridge configuration. And what that means is you do not need to modify your on-prem machines. So the bridge itself can provide the tunneling and untunneling, and you don't need to worry about updating your machines on-prem. We also had customers in their migration to the cloud. They wanted to be able to run on Kubernetes, so they weren't interested in running and managing their own hosts, basically. So we're currently finalizing the release for our host agent, or XNIC software, and it will be running on AKS, so basically Kubernetes on Azure. We also had some customers who had certain workflow restrictions. So imagine that you're generating traffic from a machine. That machine you have no control over, as in you might not be able to change the source flow that you're getting from that machine. You might not be able to even install our agents on that machine. So we had to adapt and allow the capability where you can set up the switch so it knows, hey, I'm getting this Unicast stream, and then I need to translate that and fan it out as multicast. So basically, it just further facilitates the ability of running a switch and having it run plug and play and seamless in the network. And then I'll give that to the expert on hitless merge here to talk about it.
Yeah, so my career for about 20 years has been in media and entertainment. And the last 6 in particular have been there's been, even in media and entertainment, there's been a focus on IP networking. And with things like 2022-7, hitless merge, so you have link redundancy, stream redundancy, where you have 2 copies of, say, camera 1 or whatever your program output is, and you have the receiver simultaneously listening to both paths at the same time and deduplicating. So if we're going to migrate that type of a workflow into the cloud, we need to be able to handle things that are duplicated both on-prem as well as things that need to be created and duplicated in the cloud. So we want that hitless merge so that if you have consumers, if there is a drop packet on one of the paths, everything is deduplicated and assembled in such a way that they don't see any hit on the end result or end product. So whether that's viewers at home or people who are trying to record the feed for some reason, you will not lose any of that data when it's combined. Timing and synchronization are also, if you're talking about precision timing protocol in particular, are required for 2110. There's a lot of cool things you could do with PTP, like synchronizing machines for a system, but especially for media, 2110, where you have separate audio, video, and data streams, require for PTP to be synchronized through the system so that you can align those things regardless of where they're originating, and you can mix and match audio and video. Al, I'm going to let you talk about this. This is an example of architecture.
Yeah, so basically in this diagram, we're just showing what our perspective of what an overlay network that is based on a CloudSwitch might look like. So you might have your on-prem environment where you run CloudSwitch that does bridging, and then you might have a CloudSwitch in one or multiple, so it doesn't need to be in the same cloud. You can have something, for example, in AWS, and then redundancy on Azure. And then from a user perspective is you have the same network that you're operating with, and it's extended through those environments. So at this point, just to kind of recap what we talked about so far. So the set of features that we ended up with by iterating on the product, working with customers, we have multicast support, protocol conversion, high availability, and 2 things that we didn't talk about was in case a switch isn't able to provide enough throughput for if you need to fan out more data than a single machine can, then you're able to configure a set of switches in a mesh configuration, so you're able to increase your egress throughput. And then we also provide capabilities of monitoring and doing packet capture because we're dissecting, we're opening up the packets to begin with. So in this slide, we're just providing some metrics on the switch itself in terms of latency and some PTP metrics. So I just want to iterate that the bandwidth of CloudSwitch is limited by the VM or EC2 instance you're running on. So this data was, we were doing some testing in Azure, and we were able to basically egress 100 gigabits per second because that's what the VM instance allowed us to do. In terms of latency, so the latency we measured for packets going through the switch was basically in the single-digit microseconds. And in terms of PTP precision using CloudSwitch, if you have a clock source, then we were looking at under 5 microseconds. And without a clock source, it's under 50 microseconds. And if you didn't use any of the PTP features available by CloudSwitch, then synchronization would be at under 125, under 250 microseconds. And now in the next slides, we have a recorded demo that we will be showing you all. And the first demo is going to be just instantiating switch using the marketplace. The second demo is we will go through the process. Yes?
Sorry, I didn't mean to.
Oh, it's okay.
Can you go back a slide real quick?
I forgot to ask if there are any questions, so I apologize.
Oh, yeah. You guys hear me?
No.
People on the live stream? Okay, cool. So I see you've got consumers in the second column, and that seems to adjust latency, which is kind of a weird thought as far as like normal multicast goes. So is the switch, virtual switch, XNIC, I think you guys called it.
Mm-hmm.
So is outputting more data? It's trying to synchronize all the consumers at the same time or something, or like where's the latencies coming from?
The XNIC is done in the so let me give a little overview. So the XNIC is happens on the agent side, and on the switch itself, we basically use kernel bypass. So we use DPDK in order to do the fan out, basically, and it's just a matter that we do the fan out by spreading it across the different cores on it. So basically, there's just more synchronization from the switch perspective in order to fan the data out because it knows that there are more agents out there.
And a follow-on question for that. So when you say limited by VM bandwidth, is it meaning like the number of cores that you can apply, or is that literally network bandwidth on the
Network bandwidth.
Yeah. So you can basically max out the network, saturate that, and you still have cores available on whatever EC2s that
Yes.
you're running on.
And that's basically as we're doing, things like protocol conversion, then having that because we're not CPU bound, it gives us that ability to do such things.
Okay.
Hi, I have a question about the message size. What was the MTU you're using? I mean,
Yeah. So the message size here is the MTU, and then our header, we just add a 32-byte header on top of the message.
so you were able to successfully send an MTU of 3,500 plus on Azure?
Yes.
Ooh, I would really love to know how. Okay, because that's really cool. Because when I try to use like jumbo frames on Azure, the performance goes terrible, and they've never been able to tell me why. And this is TCP or UDP that you're sending?
This is UDP.
Okay, perfect. That's exactly our use case. So,
Perfect.
Is it okay if I ask you later?
Definitely, we'd
okay,
love to.
Great, thanks.
We'd love to. And any more questions? Sure. No, too late. We only go forward.
Yeah, just
we don't
remember
go
all
backwards.
questions pipe through the mic.
So here?
Sorry, one more with the okay, yeah. So the on-prem CloudSwitch, with that one, is it pulling in all multicast data that it sees, or are you guys having to configure it for specific multicast streams to bring up into the cloud?
Yes. So it's not everything. You have full control over what you
Okay,
want to do.
cool. Thanks. Just wanted to
Thank you. So let's see how we do this. So the demo is I used this is through AWS. So big plug for AWS. This is basically going through the marketplace, and I am looking. So here I search for our product, and this is just the marketplace process for subscribing to the product. So this is just typically what it's done. So we have 3 products. So the tiers are a small switch, a medium switch, and a large. In this instance, I selected a medium switch, just because I wanted to do protocol conversion, which is supported in it. And I didn't realize it'll be so pixelated. So let me. Yeah, I can just walk you through what's happening. I'm sorry. So here I am. Basically, the way that we do our marketplace offering is we do a CloudFormation template. So in a production environment, you just need the like the AMI, so the VM ID, and that's all you need to instantiate it. We do it with a CloudFormation template just because you need 2 NICs. So you need a NIC that handles the data traffic and another for the control traffic. And we just use it in CloudFormation. We give you the best initial experience. And then you can take what we do there and pull it into however you want to do your infrastructure creation. So yeah, so now we're instantiating it. We're going into CloudFormation. We're passing some information such as the stack information, and then some security group settings. So the ingress and egress rules here, I'm saying allow traffic to go in from any source and out to any destination, because I have a jump host in there. And you can have either the control and data flow in the same subnet, or it can be different subnets. So here I'm selecting a control subnet and a data subnet. And then, yeah, there's a default security group that you can use that we create for you, or you can select your own security group. And then we just go through the process of creating the CloudFormation stack. So again, this is all resources. It's in your account. You own all of this. You have full control over it and SSH access to the machine. And as we all know, if you keep hitting refresh, things go faster. I know the AWS folks love the refresh button. So yeah, things are getting created. Eventually, the EC2 instance is created. And that's it for that demo. And for the next demo, we will actually run multicast traffic. So let me pause. On the left here, we have our, I'm logged into the switch. I'm using a tool called SwitchTop. So it basically gives you perspective on, on what agents or XNICs are connected to the switch, what data is coming in, what data is going out. So right now it's blank because we are going to do a fresh install for you. And on the right, you can see 3 agents. So in order to run the installation process, it's just a curl command. So all of the assets to install the agents are around the switch. So again, you don't need to reach out to get anything. We have some customers running in an air-gapped install configuration. So this works out really well for them. So we're going through the install process, and as we're curling there and executing the install script, you can see the agents starting to pop up on the left. So the agents are popping up on the left. So this is agent 2. Now the 3rd agent is up and ready. So right there we have the switch set up, and we have all of our agents set up. Now we can do multicast. And that's the next step here. We're doing multicast. So in the bottom one, this is going to be our producer. So I'm just running the switch perf command. So we just have a CLI tool that generates and consumes multicast traffic. So it's a good way of just testing that everything is sane. So we're running the producer. And then you can see the switch is receiving the traffic. There are no subscribers, so it's not sending the data anywhere. So that's why you only see on the bottom right corner that we're receiving the traffic. and you can't see it, but if you look closely, we're sending about 250,000 packets per second at 2.7 gigabits per second. And now we're starting our consumers. So we start our first consumer, and then you can see that we're egressing 225,000 packets at 2.7 gigabits per second, and now we have 2 consumers. So just like that, we're egressing 5.2, and we're ingressing 2.6 gigabits per second. So we're egressing 450,000 packets per second and 225 in. So that's it for this demo. The next demo, I'm going to be showing you our console. So we're going to be setting up, let me see, now I need to go here. Okay, so it's the same configuration that we had previously. On the left, the first thing I'm going to do, just because I have everything behind a jump post because I'm paranoid like that, we're going to be setting up an SSH tunnel in order to log onto the console, which again, it's physically running on the GUI. You're not going to any external resource. So the tunnel is running. Now we're going to to Wicked Eye is what we call the tool, and as it loads up, you're going to be seeing basically your network configuration. So in the center, we have your switch, and then you can see the 3 agents that we installed previously. Next, we're going to go to the settings page. And in the settings page, you're able to set up your protocol fanout. You're able to set up your mesh configuration. You're able to set up your hitless merge or your high availability. So for now, we're just going to jump in directly into our protocol fanout configuration. So we are going to set up an SRT listener for ingress. And I'll be typing those commands there. And then we are, as part of this configuration, it will egress multicast from that SRT stream. And then also I will set up an SRT caller egress path. So in case you need to consume SRT, then we're setting that up there. Sure. Yeah, we've had some customers where they can only get ingress through SRT, and ultimately they just needed multicast on the other end, just pure UDP. And yeah, and that was the driver when we added this feature. It looks more interesting when the text is actually legible. For now, it's like just another language. And now you can see that the graph has updated. On the left, you can see that we have the SRT source and the so the ingress and egress SRT paths that we just created. And then you still see the 3 XNIC agents, so the agents that we previously configured that can still send and receive multicast. And now we are generating the SRT stream. And then on the other end, we're going to open up VLC and just receive the video pattern that's being sent over. And you can see here in the graph that you can see the SRT traffic. So it's green, and there's basically the throughput that's the throughput information is on the graph itself there. And now we're bringing up VLC. We're doing the connection, and then you're going to see, if you can look at it, you can read the egress information in the graph. And now we're going to be displaying the video pattern, and that's it. We just did SRT to multicast conversion.
It's very impressive. I was curious as to, well, there's so many video applications on-prem that use multicast all the time. But as you do this and you can do this in the cloud, what applications are you finding the most traction with in terms of video?
Use cases.
Yeah, we actually have a whole slide on use cases.
Oh, okay. I'm
So yeah,
Good. All right.
Cassidy got excited when you asked the question, which it starts right there.
Yeah. So there are a lot of applications, even non-media stuff, obviously, that comes up. But for the sake of this conversation, so this is one scenario here. We talk about like a high availability with an A/B failover, right? So you have multiple things happening in the cloud. Even there's different types of manipulation happening with the signal. Maybe there's commercial insertion or logo generation or something happening there, or format changes. So you might want to do a multicast one-to-many behavior in the cloud for those virtualized nodes. But ultimately you have two separate buildings originating signals, and then you have one consumer that needs to be able to fail over between them in this instance. Now, obviously you're doing all of this in the cloud without having to ship racks of equipment or build separate facilities for your entire path. You're turning it on and turning it off. Go ahead and give me the next one. So this is another fun example, one of my favorites. So you asked about how much of that multicast from on-prem am I actually handing off to the cloud system? Well, again, you can configure it, and you can actually dynamically request it with our dynamic bridge. So this is an example where maybe you have thousands of different camera feeds. It could be some sort of a security camera application or something like that. And what you're doing is just selecting the ones you actually want to monitor at a given time. So in this case, we have multiple remote viewers. Some of them are at home or at work, and they just decide which of those signals they want to see.
Sorry,
Yeah,
quick question.
Yeah.
Can you go back a slide?
Oh, sure.
So is that then I just want to make sure I understand this part.
Yeah.
But so the viewing side, right-hand side, is that what's driving the IGMP requests on the switch side on the left-hand side?
No, in this particular instance, they would actually be remoting in to tell the virtualized cloud-hosted instances to make that IGMP request.
Okay.
So it's not a cloud ground as far as the dynamic behavior in this diagram, but that is something that's coming. Obviously, there are plenty of use cases for that.
So I think if I could follow on from my other
go ahead.
question, where this kind of makes the most sense is multicast gives you the ability to get the video signals out with essentially less bandwidth. You just subscribe to that thing, and so it's highly efficient in that. In the cloud, since it's basically in terms of the cloud providers, mainly a Unicast based network, Unicast can do a lot of this until you max things out, right? And so like as you're finding like where is the places that it's maxing out, it's if this is a security camera thing, I get it because you got like thousands and you might oversubscribe.
Like what's the number where people decide that they need to do it? Or
or how like where are you finding traction? Because there's a lot of like Unicast can do it anyways kind of thing. And
yeah, absolutely. And I think for me, purely selfishly, from an operational perspective, because most of my career was actually in live operations, production, it would be the laziness of I don't want to have to go manually configure those Unicast setups every time I change them. So this is, if I can just use IGMP, I can use a lot of those paradigms we already have in the on-prem multicast networks. So I could use a routing system, a control overlay that can talk to these things and make an IGMP request. So I could do things like live switching what these feeds are and not have to have like presets that I'm recalling or scripts that I'm running to recall my different stuff.
So one of the primary benefits is making it easier for people who are used to doing a multicast network to just you configure it more simply than
right. It's all there. You have the cloud system knows about all the multicast that's on prem, and it just has to request the things that it wants when it wants them.
And in this scenario, something that is interesting in that use case is there's limitation on, for example, the express route that they've purchased for their ground to cloud was, it's expensive, so it's at a set bandwidth. So they wanted to have things dynamically because they didn't want to push more data than their link allows. So at that point, we had to add the dynamic bridge capability just so they can remove things in and out and control what's coming out, just so they don't they don't reach the channel limit there.
Yeah, I like efficiency also. We talked a little bit about that hitless packet merge earlier. This is an example of the on-prem sender and receiver creating that duplicated stream and then receiving it and deduping it. And then we're using a high availability configuration in the cloud to transport everything. Now, here we actually show precision timing protocol moving along as well. So you can think of existing 2110 systems, for example, and they want to extend from one facility to another while using some of those cloud resources. You could replicate the 2110, the red and the blue, and the PTP behavior they expect, and have the other side connect to that network, and things can feel as if they're all the same network.
So is the PTP in the cloud PTP-like, or is it PTP?
That's a good question. Yeah, well, what depends on what PTP you mean, right? Yeah, yeah. So it is right now. It's PTP Unicast primarily. There are things we can do, obviously, with our protocol translations and things to make it multicast, but it's. I would say that there are still details we need to add to make it more of a smooth 2059 style PTP, right?
So then, is it derived from the RTP timestamps? Because that's like with -7, right? That's kind of what it's based off of.
The deduplication. Yeah, you're basically finding the sequence of the packets and then realigning them. Yeah, and then the timestamps are helpful if you have things like maybe video is originating in one part of the world and audio is in another part, and you need to actually know what the clocks were on those things. Yeah. And then maybe you have a device where a human was able to interfere and adjust the lip sync and then have it stay from that point forward aligned based on the RTP stamps. So that's true. As far as where the master clock comes from, we're finding it's a little bit different in every cloud environment, right?
Right.
So
yeah, because I mean that's especially with the precision of PTP, right? Having multiple grandmasters, if you will, is
one of
kind
my
of out of the
favorite things
question.
about PTP when I first started to study it for media applications was the idea of sync islands and having more than just the A and the B. I could have 8 different PTP masters that were negotiating with each other. So that best master clock algorithm type of behavior, we can do things like that with boundary clocks and clocks. But we're adding things rapidly all the time.
It's a super difficult problem.
Yeah.
That's for sure.
Yeah,
Cool. Thank you.
absolutely. Yeah, give me the next one. So this is just an example for fun. Go ahead. Yeah.
So yeah, I'm like the anti-PTP person. And
I love PTP.
Anti-sync stuff, all that kind of stuff. Just to let you know, okay,
That's okay. Let's
to
arm
be
wrestle
calibrated.
later. Let's do
Okay,
it.
so like, are you like re-stamping stuff in the cloud, or why do you need PTP up there if you're not just passing the timestamps on?
Correct. Yeah. So if you have a situation, and actually that's perfect setup for this, because the example that I'm showing here is maybe you want to do an entire channel assembly or create an entire, from the time you recorded something with the camera to the time it was put together in a master control workflow and commercials were added. You could do a ton of that in the cloud. I mean, we see that every day, right? People announce you can put a production switcher in the cloud. You can put a multi-viewer in the cloud, so on, so forth. So if you're using those types of devices that are going to be manipulating things and maybe even assembling disparate audio and video and data streams, having the ability to actually move that PTP so that they understand it, because that's how it was created on-prem, that's one major use case.
But we do that by conveying their timestamps so that they get them at the end.
Right.
And as long as the timestamps are moved along with the media, it kind of doesn't matter, well, in my experience, how synchronous you are in the cloud, as long as you can present the impression that you are synchronous at the edges. So
Right.
I don't know. I think that...
Well, there's ways to free run an SDI and other things too, but some things work and some things don't.
Yeah, I don't know.
I think for a live sports workflow in particular, where it's a live sports production facility using 2110, the expectation is going to be that it looks and feels as similar to that on-prem setup in the cloud as possible.
Yeah, but the cloud is so different. You might as well take advantage of its differences. And what you're trying to do here is to like make the cloud look like the ground. And that's an impedance mismatch, in my opinion. But
and I think
I will shut up from here.
I agree with you. No, I agree with you to some extent. And I think part of the, and this was the same when we had 2110 in its infancy, and I mean, some people would argue it's still there. I've seen over 40 systems go live that I was involved with designing for 2110, and we always had that question of, are we just recreating SDI and IP, right? And I think only now people are starting to push beyond, you know, and that's the same thing with the cloud, right? We have to kind of make it easy for people to extend their systems into the cloud, but then we can add all those other things too. I'm not against anything that you're saying, by the way, because we can do it both ways. That's fine.
Maybe just to kind of add on to that, or kind of clarify in a different direction. So what you're showing is really kind of a live production type of setup in the cloud. And a lot of the vendors, be it an Everett's or a Ross or a Grass Valley, they've got their things in the cloud, and a lot of those productions today are done in, say, NDI. Mm-hmm. In NDI inherently, if you're in a on-premise, it can do multicast. In the cloud, it's traditionally Unicast, and people are kind of getting things done with Unicast and NDI. Not that I'm a fan of NDI. I know timing, all the different things, but like adding this to it, like what can you do differently, better? What's the plus alpha?
Yeah.
With this, yeah.
Yeah. Well, so first I'll say, you know, we actually like NDI as well, and it's another thing we know that by being the network switch, even as virtual, we have to be able to support that. And I'm sure there will be nodes that move systems that are mixed NDI and other formats between each other. I think, again, mostly the advantage is going to be that familiarity. And we've actually seen things with our partners that we'll be talking with, you know, and showing things at NAB where maybe you have an application that was designed with 2110 in mind, and you can actually just use a lot of those same handles and features. Just turn on, oh, I'm going to send an IGMP join for some 2110, and there it is, right? Because they already designed it for the on-prem workflow. So it's not just the operational consumer or customer who needs to be able to have that familiarity. It's the actual designers of the applications. Yep. Yeah. So what can I do in the cloud today? Just to recap, we can do one-to-many behavior, even SRT to a mix of multiple SRT, Unicast, and Multicast destinations. We can conserve bandwidth with that dynamic bridge, so we can treat cloud endpoints as dynamic multicast subscribers. We have stream redundancy. We can even spread those streams over separate paths and different regions, availability zones. We have high availability, so we could have duplicates and triplicates and so on. And synchronous performance with low latency PTP to keep the nodes on a shared clock, for whatever reason you might have. And we will be at NAB in multiple booths. We're going to be with Microsoft Azure, Tag Video Systems, and Evertz. And you can come see us and see some of these things live and some of the workflows that we talked about in the examples. And we're happy to work with everybody and talk to everybody about what you're trying to do in the cloud. So with that, thank you. And Al, I'll give you the last thank you and the last word. If there's any more questions, you guys can throw them at Al.
Thank you for having us here today. It's been fun. If no questions, that's it for us.
All right, let's take a